Imagine it's 2 a.m. The entire city is asleep. Suddenly, a deep rumbling rises from beneath the floorboards. The windows rattle and your bed starts violently shaking in the pitch black. By the time the shaking stops and the power goes out, people are already rushing online in a panic. Social media immediately floods with the exact same question: why do these always happen at night? It certainly feels true. Waking up to absolute darkness and losing control of your surroundings is uniquely terrifying. Our brains are hardwired to prioritize and record life-threatening events, especially those that happen when we are physically vulnerable in our sleep. Because those midnight alarms are so vivid, we trick ourselves into thinking they happen frequently. Psychologists call this availability bias. The events we recall most easily seem far more common to us than they actually are. But human memory is a terrible substitute for statistics. To figure out what's triggering these tremors, we have to put our fears aside and look at the cold, emotionless geological data. We need to find out whether the planet is genuinely targeting us while we rest, or if the darkness is simply playing a massive trick on our perception. To find the answer, we have to travel nearly 100 kilometers beneath our feet. The Earth's outer shell is broken into giant slabs of rock called tectonic plates. These enormous pieces slowly grind against each other, eventually locking together under immense pressure. That mechanical stress accumulates for decades, sometimes centuries. The rocks are responding to heat and friction building at a glacial pace, entirely disconnected from the position of the sun or a clock on your wall. This chart maps millions of recorded seismic events. The data shows that earthquakes occur at a nearly equal rate across every hour of the day. Look closely at the data from midnight to 6 in the morning. There is absolutely no spike in activity. The tectonic plates don't pause their movement for daylight, and they certainly don't wait for us to go to sleep. Many people still point to the sky, assuming the moon's gravitational pull might stretch the Earth's crust and trigger these ruptures. While the moon does create tiny stresses inside the crust, those forces are incredibly weak compared to the massive energy already stored along major fault lines. Since the mechanics of the subterranean rock and the celestial bodies above us don't factor in our sleep cycles, the root of this midnight myth has to be found right here on the surface. During the day, human environments are intensely loud. Cities are packed with cars, construction equipment, subways, and thousands of walking pedestrians, all creating a chaotic hum of mechanical energy. All that urban activity generates constant, heavy vibrations. The ground is literally buzzing, which easily masks the tiny, continuous seismic waves rippling under our feet throughout the afternoon. But at night, the environment completely transforms. The heavy traffic disappears, factories power down, and the background noise drops to near zero. When you go to sleep, you're lying flat on a flexible mattress. That's are actually highly effective physical amplifiers. They catch tiny seismic waves from the ground and bounce them through the springs and wooden frames. A minor tremor you would never feel while walking down a busy sidewalk suddenly travels straight through your mattress and into your spine. Your resting body temporarily acts as a highly sensitive biological vibration detector. Mechanical instruments have always recorded this reality. Seismometers track these minute tremors 24 hours a day, capturing the ground's constant shifting, even when our daytime activities blind us to it. Nighttime silence removes the masking effect of human activity, making the planet's constant motion impossible to ignore. However, this doesn't mean nighttime earthquakes are harmless. While the shaking itself isn't stronger in the dark, the circumstances of the night make the exact same magnitude event objectively more dangerous. When people are violently shaken awake, their reaction times are incredibly slow. Worse, earthquakes frequently sever regional power grids. This traps families in pitch-black buildings, making standard evacuation routes nearly impossible to navigate. It's these specific logistical failures that lead to higher casualty rates. The severe destruction and loss of life embed these nocturnal tragedies deep into our cultural memory, fueling the myth that earthquakes only strike in the dark. Since we can't predict exactly when a fault will snap, our primary defense is early warning technology. When a fault ruptures, it sends out fast-moving primary waves, or P waves, that race ahead of the slower, highly destructive secondary shaking. Sensitive monitors detect those initial P waves and instantly trigger a digital alarm. That provides a few precious seconds of warning, just enough time to automatically halt passenger trains, shut off regional gas pipelines, and pause delicate surgeries before the violent shaking arrives. These sensors remind us just how active our world truly is. Globally, the Earth's crust fractures and shakes more than 500,000 times a year. The Earth is a restless, dynamic machine that never actually sleeps. If scientists could identify the precise start of a rupture 24 hours in advance, how do you think the world would change? Let me know your thoughts in the comments, and I'll see you in the next video.